find the dot product of these two vectors. We have u equals 1i plus 1j, and v, which equals negative 1 plus j. Also, we want to find the angle between them and determine if the vectors are parallel, orthogonal, or neither. All right, so there's a formula to find the angle between two vectors. It's cosine of theta is going to equal the dot product, and that's on the numerator, divided by the magnitude of u times the magnitude of v. So we actually have to do three different calculations here, right? First we find the dot product, then we find the magnitude of u, then we find the magnitude of v, divide them out, and then we see what that angle is, right? So if you think about that, right, if the cosine of theta is equal to 0, then we know that theta is 90 degrees, right? Because that's where cosine is equal to 0, right? Then theta is equal to 90. Well, it could also be 270 degrees, right? But then that's just the right angle, right? So if cosine of theta is equal to 0, then the vectors are orthogonal, right? Remember, orthogonal just means that they cross at a right angle. On the other hand, if cosine of theta equals 1 or negative 1, then we know that the angle is 0 or 180 degrees, and then the vectors would be parallel. Any other situation, it doesn't really matter, right? So really what we're interested in is, well, is cosine theta equal to 0, or does cosine theta equal 1 or negative 1? Now let's look at one more thing here, right? If cosine of theta is equal to 0, right, in this particular case, the dot product must equal 0, right? So actually that narrows things down quite a bit, right? As long as the dot product is equal to 0, we don't even need to do this step, right? If the dot product is equal to 0, we know that these vectors are orthogonal. Okay? So then if we don't get 0, right, then we actually have to complete the problem to determine if the vectors are parallel or not. Okay? So let's do that first, right? Let's just find the dot product. Okay? So u dot v in this case, we get, so u is equal to I plus j, and then v is equal to negative I plus j, right? So to find the dot product, we get 1 times negative 1, which is negative 1, plus 1 times 1. Add these together. Oh, look at that. We get 0. Okay? So we don't even need to complete this formula here, right? The dot product is 0. That's the numerator. Doesn't matter what the denominator is, right? We know that cosine of theta equals 0, so these vectors will be orthogonal. Now, we don't need to draw these out. Okay, but in this case, we could do so, right? Just see what we get. And, okay. Let's draw these out, right? So we'll do vector I, which is 1 plus 1, or 1i plus 1j. So this vector here, right? This is the vector u. It goes something like this, right? What about the vector v, right? It's going to be negative 1 plus 1 here. This vector goes up a little something like this, right? This is the vector v here. What do you notice about these two vectors? Okay. Well, they form a right angle. Remember, vectors are not defined by where they are in space, right? Okay. They are defined by their magnitude and direction. But if you look at this, right, no matter, we can place this vector anywhere that we want here, but we notice that they will cross at a right angle.